the last one before you finish this one?
But you can register for December right now, right?
No, it's close, I think. Okay.
It's close?
I'm an idiot. I should have been like, hey, let me take this test
this
before
Saturday.
it gets worse.
It's this Saturday?
Yeah.
No, it gets easier.
But
Wait,
but it was like
this is not December though.
summer. Like,
December doesn't.
I don't like that it's easier.
Huh?
Because it makes it less impactful.
Oh.
Like, oh yeah, a 1350 for someone could be different than a 1350 for another person.
But
So it's like, what's the point of having a score if it doesn't, if it's relative? Subjective score, then what's the point?
SAT is dumb. What?
Maddie, you okay?
oh, you're gonna get that back, man. I'm on
All right. So, any question from Yesha's homework? So 11 is not that hard. It's actually very easy. 14. Okay, what's the 14 says? 1 minus cosine square of x and what? Secant of x. It just write it out.
X minus sine plus secant. He died.
that was much easier.
Any question from yeah.
I got a question for like, where it's like a question like, what's the only would be I think I got the rule right. I'm not sure what that's.
Could be is because they don't give you the initial condition, so you don't know which one is. You want to do the best you can, so just take whatever integral you have.
Whatever it looks like it. the most.
Yeah, the look like the most.
8 and 9, they're like the same.
Kelly just told me to just look at it.
Number 8?
I feel like it feels wrong though, you know.
I know, but she's like, that was like the only one that was squared over 2 plus 9x was C.
Yep. Next questions.
Wait, but
Yeah,
Because our rule is
No questions?
where?
Can I move on or no? Ding, can I move on? Ding never talked to me. Ding doesn't like me.
Wait,
look. You see, if you do power rule right here, right?
I don't know what Ding sound like.
Your power rule, it's not this plus 1. It's
All right,
It
so
would be
It's
2
oh.
times n plus 1. It's like this keeps
It's like 1/2
Oh.
It's like if you split the fraction, that's how it's.
all right, so what is let's just review a little bit. What is a general solution, right? General solution, just say, for example, you have something like this, or like say f prime of x is equal to x, and you say, hey, can you find f of x, and that's going to be x squared over 2 plus c. So this is called a general solution. Now, particular solution is a little bit different. Particular solution says f prime of x is equal to x, and f of 4 is equal to 2, something like that. Or f2 equal to 6. Then you can integrate this x dx, and then you can say x squared over 2 plus c. And then you can say, okay, well, I have this is initial conditions. And then you can say 6 equal to x squared over 2 plus c. And you can say 6 equal to, you're going to plug in 4. So it'd be 16 over 2 plus c, where c is equal to -2, I think. So they can say x squared over 2 minus 2. That would be a particular solutions. Of the differential equation. differential equation. So that's something that we already did for the last 2 days, whether it's trig or just regular x, right? So we call this indefinite integral. And as you see on the stream today, the title I titled it to definite integral. And so we're gonna talk about what is definite integral.
Does this have to do with those numbers that are by the integral symbol?
Ah, that's a good idea. So we're gonna talk about that. So what's the difference between definite integral and indefinite integral? Is one is with the boundaries. So definite integral is the one without boundaries. So it'll be like something like this, f of x, and it must have a dx in the back. A lot of people don't write a dx. It's not okay if you don't write down dx. It's like plus c. Now there's a two value here. One is right here. One's right here. This is known as the lower bound. And this is the upper bound. This is the height of a function. And this is the width of the function. You're gonna be like, what? So much stuff that is very complex. I don't disagree with you. Right now, we're just gonna look at it as this, and we're gonna explain each part by each part. Why do I need a height? Why do I need a width? Now let's define width. Dx is also known as delta x. That means small changing of x. And this small changing of x is equal to the upper bound minus the lower bound divided by n. And you're gonna be like, what is n? I just introduced you a whole bunch of crap that doesn't make sense yet. And we still haven't explained what's definite integral. So let's start with history. In 1600, Isaac Newton found two problems. First problem is he trying to find how fast the planet moves. In order to find out how fast the planet moves, so for example, this is Jupiter's moving, right? Like this is elliptical movement. In order to find the speed of the Jupiter or Saturn or Mercury, he needed to find out the equation of tangent line. So that was the tangent line problem. So you know what make great mathematicians is, or what make great at something is they discover a problem and they fix the problem. So first you have to discover a problem. They discover the tangent line problem. And you want to find out the speed of something, you really need a tangent line. The second problem, he says, well, if I have a velocity equation and I can find out, how fast how much distance to travel, then you really need an idea of the area under the curve. So if you area under the curve, what does that mean? Imagine I have a graph, and the graph looks something like this. Sorry, that's not good. So something like this. And I want to find from here to here, I want to find this particular area. So that was the second problem that he has trouble with. So the problem is area under the curve. For first problem is tangent line problem. The second problem is the area under the curve.
Is it just infinitely small rectangles added together?
Well, we'll get to that. You're not wrong. So area under the curve. So there's no geometry that can help you to find this area because it's not a defined shape. It's not a rectangle, or not a trapezoid, or not a circle, not a, I don't know, hexagon. You can find all those area using geometry. Calculus kind of overrides that. So back then there's another mathematician. I forgot his first name, but I know his last should be Riemann. Riemann started with approximation, and we're gonna study that approximation later. Okay, so we're gonna show you what Riemann said. Now, what Riemann proposed is break up to few rectangles, just like what Min says. Break up few rectangles. So I'm gonna show you how to work. So I'm going to break up to 4 rectangles. And later we're going to learn all this kind of approximation on the left hand side. Do you see all the, oops.
Whoa, that's a lot.
Okay, we're going to learn all those approximation. The trapezoid approximation, the midpoint approximation, the left end approximation, and right end approximation. They are 4. Sometimes in competition, we actually learn another one called Simpson's rule. Which is normally you don't have to use it, but sometimes in the OBC test has something to talk about Simpson's rule. Right now we don't need to do Simpson's rule. Right now for AB and BC only need to do trapezoid, midpoint, left and right, Riemann sum. Right now we're using a right Riemann sum. And I will show you the area. The actual area is 5.25. Do you see that actual value on the bottom? Do you see that 5.25? Right now the approximation is 6.515, which is, yeah, pretty shitty approximation. How do I make it the calculation better? Make rectangle smaller. Okay, so let's make like 8. Now it becomes a little bit more precise. You see that it's 5.84 now. All of a sudden it went from 6.5 to 5.84 approximation. So it becomes more exact as I'm going. And then you say, okay, well, how about I'm gonna go with 16. Now look at the area, 5.54. You can break it to infinite amount of pieces though. So Riemann says we can break up more pieces. We just do calculation by hand. Newton says no. Newton says that's too much trouble. So back then, like a mathematician, they have math duels. They challenge each other, like who's better mathematicians, right? And people more like, so back then, like, you know, if you had publicists, then you're gonna become more famous. For example, like people come up with Pythagorean triangle, Pascal triangle. The Pascal triangle was invented by 300 years before that. There was a Yang Hui triangle, which is a Chinese guy. And before that Chinese guy, there was a Mount Merle staircase. Is almost 1,000 years before Pascal triangle. But Pascal is white. He gets all the credits. I'm just kidding. So I'm trying to say is, back then there was mathematician. They always have debating with each other. And they always, like the more famous people, they usually get the credits. So Newton probably stole a lot of people's work. And probably stole a lot of work from Newman, Riemann, or other I saw this movie. He stole it 30 years ago. He stole Newton's method. It's something called Newton's method. He stole it from another mathematician named Joseph. So back then they steal from each other.
Your computer stopped streaming.
Why?
I think your computer timed out. You talked about time.
When I said something about white guys? Okay. I'm just kidding. I love white people. No, I don't. Okay, so it becomes more accurate as more things I go. So I'm going to show you what happened if I go to, let's say, 1,000. And my approximation is very close, 5.25. It's still a little bit off. But if you look at it, do you see why they are a little bit off? Right? You see why they're a little bit off. Still, in infinitesimally small, they're still missing those edges. So that's right. The trapezoid rule is a better approximation. We're going to talk about trapezoid because instead of build rectangle, huh?
What was this one called?
This one's called right end point rectangle Riemann sum. It's right there in front of you. Okay, so but if you do trapezoid, it will be much better. So I'll show you the trapezoid.
Can't make n. Did you make this Desmos?
No, hell no. I'm not that smart.
Desmos, right?
So is the definite one bounded? Or...
Definite is bounded. Yeah.
Okay, and then the indefinite is not bounded.
Yeah.
Okay.
Okay. So with that being said, I'm also gonna show you an equation that is called and you can write down this equation, but I'm not gonna talk about it. This is called a definition of integrals. No, just write it down. You don't have to use it. We're not gonna teach it. There is only one question on AP exam, and there's only 30% of the chance to show up on multiple choice. So I'm not gonna teach you guys. Now I'm gonna make a video about it if you're interested. Let's just say if you also another thing, if you want to go become an engineer and if you want to go UCF, and UCF engineering program is pretty good, but if you score a 4 on AP exam, they don't take your credit. They'll ask you to retake it. So you will have to learn Calc 1 in UCF, and they will talk about definition of integral. This is called definition of integral. It's called general form of definition of integral. This is actually right an approximation. So I'm going to start with something that A is going to be the low bound. So low bound.
Is it a 1 or
I is I. I is a number.
Yeah,
form.
I equals at the bottom of
I equal to 1.
I
So let's talk about this. This is the integral, which is area under the curve. But he says the formal definition is this. It's limit n approach infinity. Why is n approach infinity? This also summation. This is lower bound for the summation. Lower bound for summation. What is summation? That means just you add up all the pieces. So you add up everything. So that's like, for example, 1 plus 2 plus 3 is the summation of I between, so summation of I, and this is 3 of n, of I here. Sorry, n equal to 1. I equal to 1.
What symbol? What is that?
That's called summation symbol. This one just means, that means just 1 plus 2 plus 3. This just means that you start at 1, end at 3, and the things you plug in is to start from I. If the I square is going to be 1 square plus 2 square plus 3 square, you learn that in Calc 2. That's why we're not teaching this particular part. But I'm just going to show you a little bit, but it's not too crazy. Now, here the delta x, we already explained delta x. Delta x is b minus a over n. And this delta x is this. That's the width of each rectangle. How do you find the height? You plug in the value into the f. So a plus delta x times I. I is the order of numbers, like 1, 2, 3, 4, 5. So you're adding the first width, you're adding the second width, you plug in the function, you find the height, and you get that. But don't worry if you don't understand any of this. I think Madeline is already giving me a face like, I don't understand this. I completely understand with you. And I'm not going to teach you. Don't worry. I'm going to make a video on the side. If you're interested, you can learn from it. I already did that on BC. They have to learn this in one day. So,
Wait, what did you write next to A?
next to what A?
The A. What does that arrow say?
Lower bound.
Okay.
And the same thing is lower bound here. And this is the upper bound.
Okay. Wait.
So how is I and A both next to them?
I is not, no, this I is lower bound for the summation.
Oh,
It has nothing to do with integral. Yeah, they are multiplication simple. So you can think about that as a dot. So if you're interested, I will teach you. But if you're not interested, it's not end of the world. It's only 40% of chance you will show up one question multiple choice. I'd rather spend 2 days on something else that it will cover like 3 questions or 2 questions. So I'm not gonna do any of those. Don't worry. But I will tell you later about other things. But later on, we're gonna say, okay, well, we're gonna start today with geometric integral. Let's see.
You can use a scroll, but the scroll wheel on the side.
it has to be, bro.
I'm gonna there. I'm stubborn. I'm gonna be there. Okay, there we go.
And he writes Zoom in.
So
73 pages.
I have 256 pages on the other one. Geometric integral. Okay, what's geometric integral? So, hey, I just want you to integrate between 1 to 3 of 4 dx. Let's see if you can find out what that is before I teach you. Now, I would never teach you how to do definite integral. We're going to teach you tomorrow or the day after. We're going to teach you probably Monday. But right now, if I don't teach you, how do I use geometry to find out the area of this?
Well, is it 24?
Nope.
Is it,
It is 8. All right, so the answer is 8. But how do you get 8 though? What? It is 4 times 2, but you have to understand what is 4 times 2. So we have a function. We have a function says A. That is the function f of x. And the f of x is equal to 4 because this is 4. That means the function is 4, right? And we want looking for area from 1 to 3, which is, guess what?
Oh, so it's
2 times 4 is equal to 8.
Like, can you explain that one more time, please?
no. So if dx is delta x, you do 3 minus 1 dx. That's like the area.
Oh, 3 minus.
Yeah.
Okay. So what is that?
Because it's 1 to 3, right?
Like
That's
on the
delta.
x
So pretty
coordinate?
much just the bound
Yeah,
is
on
from
the-
x.
That's equal to
Change
And
since
then
the
you
bound,
multiply it by
the
the
domain
function.
is 1 to 3.
The height.
That means there's
Does that
going
make
to
sense?
be two spaces
Oh, because
right there.
f of x is equal to the height.
Okay.
Oh,
So this is there's going to be two
dx is the width.
two values in between
Right? On the
the 1 to 3
plus.
because 1 to 3.
and you
Yeah.
you're trying to
And
find
then
the
you multiply
area.
that by 4 because it's multiply. Yeah. So
Finally, I understand this for the first time.
All right, so shh. Okay, it's 8, not 12.
She was just asking about like a different scenario.
Yeah, it was like
Oh.
1 to 4 instead.
Oh yeah, 1 to 4 is B12. Because you got more area to cover, right? So now I got another one. It was 2x plus 3 dx. Between 2 to 5, it just between x value to another x value. So with the same idea of using geometry, can you find out what the area is? We're not teaching you how to find integral yet. We haven't given you that tool yet. It doesn't mean we won't give it to you. We will give it to you next week. But right now, you want to understand geometry.
So you get yeah.
6x looks like.
No, 6 yeah.
But then what is x?
You said it's a 0?
No.
Right now, we're just using geometry. We're not using any calculus, just basic geometry. So I limit down the tools down to just geometry, simple geometry.
I swear it was only a rectangle in the last one.
No, because it's like a.
Oh yeah.
Tony sounds pretty smart today.
Rectangle.
What the hell?
Oh, because if you think
7,
about it,
13.
2x plus 3 looks like it's a linear line.
All right, so shh. I'm gonna stop you from here because I hear people say it's rectangle and triangle, and I don't like that. I'm gonna explain why I don't like that. Because there is something called a trapezoid rather than rectangle and triangle, and I want to teach that. And for what I discovered from the last 2 periods combined, I have 60 to 70% of people doesn't know the area of a trapezoid. Raise your hand if you don't know what's the area of a trapezoid.
If you know it.
You don't know.
Pretty fresh.
You don't know? Okay, 1, 2. You don't know either? How'd you pass the SAT with 770? Area of a trapezoid. 1, 2, 3, 4, 5, 6, 7, 8, 9. Have a dash? No. 10, 11, 12, 13, 14, 15. Holy shit. This is crazy. It's on my son's FSA test at 6th grade. It's crazy. Anyway, so one thing I'm proud of you is this. You're not afraid that to say you don't know. I think that's good because a lot of time, like if you don't know something, just says I don't know. It's no big deal. Don't be hiding it. I have all the students like in my other class before is always hiding it. Says I don't want to show my weakness. Look, you gotta learn. Like I say, last year I have a student doesn't know how to multiply 2-digit number.
This year too. I learned this year.
You learned this year. At least Chase is honest, right? So 2-digit number, 32 times 8. The kid write 32 plus 32 plus 32 plus 32 plus 32, added 8 times on the test, on the paper. I'm like, what the hell? So we eventually teach them how to do it. So it doesn't matter. If you don't know how to do it, learn it. Okay? I'm gonna teach you how to learn it. So it's gonna have this is a y-intercept, this is slope. So this is gonna be like this. So it's straight line. And between 2 to 5, it's like this. Okay, so you got a trapezoid. Now, not a normal trapezoid you learn in elementary school. In elementary school, they always do like trapezoid this orientation. And this is always a height, except this height is on the side. So this is the H. Now, the H here is 5 minus 2, right? So H is equal to 5 minus 2. So, but the problem is we need to know what's area trapezoid. Because why we need to know area trapezoid? Because, and I hear some people says the trapezoid is a rectangle plus that. No, I want you to memorize something else because you need to learn how to something called trapezoid rule. The trapezoid rule is gonna be, for me, I don't know. I don't remember what the trapezoid rule. I'm gonna be honest with you. I don't know. Why? I don't know because I don't need to know. I always think of it as rectangle. I'm gonna show you why it's rectangle. It's base times height for rectangle, right? So then if you can, but the problem is two different type of base. There's a base 1. There was a base 1 here, and there's a base 2. Now, base 1 and base 2, you can average them. Why you want to average them? Base 1 plus base 2, and the average you divide it by 2. Why do you do that? You're going to find out the average is between, so this is how many unit? I don't know how many unit. And you take this average. So let's just say this is 7 unit, and this is going to be, if I plug in 5, it's going to be 13 units. So if you do 7 plus 13 is 20. 20 divided by 2 is 10. Now, I'm going to count to 10. I'm going to show you what happened. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I'm going to draw a rectangle here. Do you see this area fit into here? Okay, so that's why you find the midpoint of that thin line, you can feel one triangle to the other side. So that's why you average your two base. Multiplied by the height is the H. So it'll be 7 plus 13 over 2 times the height, which is equal to 3. So therefore it's 10 times 3, that's equal to 30. So this one is 30. 3 is the bottom, is 5 minus 2 is equal to 3. It's the height. So base 1 plus base 2 divided by 2. Now some people says, how do I know the height? Well, I plug in the 2 in here. If I plug in the 2 in here, I find out one height, right? That's equal to 7. If I plug in the other one, I find out the other height, which is 13. I can plug in, I can evaluate those. There's 16 students in this room, and there's 15 kids doesn't know aerial trapezoid. You are one of them? Is the average of the base? Yeah. Okay, so do you understand? So you can practice on this one, but I'm moving on. But the next thing is I want to do is this one. So I remember one day there was a Ty Matthew come into my room. Mr. Ye, I'm good at math. I take a double block. I said, okay, great. You are good at math. But he didn't understand. I hate people saying that. Because if people are good at math, they will not say they are good at math. They will show you they are good at math. Okay? So Ty Matthew walked in my room, says, by the way, he is good at math. I'm not putting anything lower. And I knew he said that, so I find a way to trap him. So he come into my room, and he says, Mr. Ye, I'm good at math. I take a double block. I'm such a badass. And I'm okay. Great. I want you to do this definite integral right here. Between negative 5 to 5, square root 25 minus x squared dx. And he's like, yeah, I got this. So he go on the board. So all the class is watching him. Most of my students know how to do it. And he didn't know how to do it. So he was writing. And he was like, he starts sweating. And And everybody just kind of observe at him. Oh, he was making fun of somebody. He was making fun of like Marion, like you don't know anything. And I got pissed. I was like, you don't ever say that to my student. You're not that smart either. So I posed this question to him, and he didn't know how to do it. Miriam knew how to do it in his heart, in her heart. Miriam was really smart, by the way. What's her last name? Kadar? She's in the Science Olympia.
Yeah. Oh.
Start with a Q.
Quater.
Quater?
Q
Yeah.
A P I R. Q A P I R.
Yeah.
Kadar?
I never know how to pronounce her last name.
I just remember.
But Marion was sitting there and laughing because Marion knew how to do it, and he was making fun of Marion, so I knew that happened. So anyway, how did our student was able to do it? Because we talk about this, we spend time to talk about this. Double block didn't have that time to talk about this type of questions. So how do we find the integral between -5 to 5 square root of 25 minus x squared dx? Does anybody know how much time I have? You got 2 minutes to think about it. Prehistoric. Prehistoric. You had to erase on your own.
Oh, is that circle circle equation? That was like Methodist.
All right. It seems like a lot of you guys didn't know what to do.
Is it
Yeah, go ahead.
25 pi over pi? Wait, 25 pi over 2?
Yep, that's good. Good job, Ethan. Okay, so what Ethan see is this is the equation, right? And I'm gonna make sure that you understand this equation. You can square both sides, so it's gonna be y squared equal to 25 minus x squared. And you can move the x squared plus y squared is equal to 25. Now you know what shape this is.
Oh, I see.
This is the circle equation for SAT. With a radius of 5, now I'm going to go back to solve for y. Now I'm going to do that again. Why do I do that again? Because y equal to square root of 25 minus x squared. But it turns out there's a plus minus. The plus part represents top part of the circle. So let's just say if I have a thing here, the plus part is to represent this part, this part, this part, this, oops. This part here. So this is this part of the circle. The minus part represents bottom part of the circle. So they only want a top part, so that's the area of top part of the circle. So that's equal to pi r squared divided by 2. The radius is 5, and that's equal to 25 pi over 2. Okay, so let's go to the other one. And this is also another question that will trip up students. Because algebraically to do this question is way harder than geometrically understanding. So you have to understand geometrically rather than algebraically. No, it's absolute value 2x minus 1. Yep.
It's too much. Wait, is that house? Blue house?
How are you doing? That's not an integral.
He's graphing.
If you think about it.
Is it like an absolute value thing? with,
I need
like,
coffee.
limit?
I'm gonna get coffee.
Okay, Mr. J.
Starbucks, here I come. Donate to Starbucks stock. I should buy stock for Starbucks. Putting all this money on the Starbucks, I might as
You drink
purchase on the
Starbucks, you don't
stock.
get cancer.
Do you have the app, Mr. J?
Why would you get canceled?
Sign up for the rewards program.
I do. I have like 400 points in there.
Not
It's scam.
No,
I can't hear you.
Oh, you're right, you're right.
I wanted to silence them. Oh, yeah.
Yep.
Like, what American football?
Tommy's a green, bro.
I was not talking about Tommy. I was talking about Tommy.
Tommy's still green.
Tommy Mazzaro?
Yes.
I didn't know him.
All right, so I'm gonna talk about this one in a second. So stay a little bit. If you think about it here, you want to find out where they intersect the 0. So 2x equal to 1, x equal to 1/2. Now what happened is you're gonna draw a line, and that 1/2 is gonna be something like this. This is a 1. 1/2 is gonna be something like this, right? And it's gonna be -3 to 4. So now what happened is this is a 1/2. From here to here is 3.5. Does that make sense? Because 3 plus half, right? And from here to here is 3.5, right? Now, can I find out the y value? Well, we can. We can plug in 4 into here. So that's going to be 8 minus 1, so 7. And we can plug in -3 into here. It's going to be -6 minus 1 is -7, but absolute value is 7. So actually just 3.5 times 7 and times 1/2, but times 2 because of 2. So this will cancel out. That's equal to 24.5. And that's how you find the area of this.
He's definitely pretty funny.
Kelly, shush.
It's always the last question.
shit, I got on tripping.
And people still got it wrong anyway. So.
Yeah, people still got it wrong. I even told them it's on the test. People still got it wrong.
Popular.